Hi, everyone, and welcome to today's webinar. Before we kick off, I just wanted to go through a couple of quick housekeeping items. Your platform is fully customizable. You can expand or collapse any of the modules. You can drop your questions for Muhammad in the questions module here on the platform, and he will answer them in the chat throughout the session. This webinar will be available on demand starting later today. You can return here over the next 2 weeks to watch it at any time. I'm thrilled to welcome our speaker, Muhammad Santos, data scientist at John Snow Labs. Today, he'll be giving a presentation on zero-shot learning for semantic relation extraction from unstructured text and how it can apply to and benefit the healthcare industry. So without further ado, over to Mohammed.
Hello everyone, I'm Mohammed. I'm working as a data scientist in a healthcare team at Johnson Labs. Today we will talk about zero-shot learning for semantic relation extraction from unstructured text. Here is the agenda. We will talk about, we will start with introducing Spark NLP library, then we will go through Spark NLP for healthcare and its components. Then I will try to explain how we use clinical relation extraction in Spark NLP. Then we will explain zero-shot learning for relation extraction in Spark NLP library. At the end of the webinar, we will have a live demo session that I will try to show you how we use zero-shot learning in clinical relation extraction in our library. Spark NLP is an open source library which is released in 2017. The goal was to create an NLP library that would require no other dependencies other than Spark itself. Also, it should work on clusters, since no other libraries could work on Spark clusters. We also wanted to take the advantage of transfer learning and implementing the latest state-of-the-art algorithms and the models in NLP research. Today, we have daily 65K downloads and also 1.7 million downloads in monthly. Totally, we hit 27 million downloads so far. Spark NLP supports Python, R, Java, and Scala languages. We keep Spark NLP up to date and upgrade it in every 2 weeks with new releases. So far, we have more than 85 total releases. The goal is to create a unified library for all NLU and NLP tasks. You can see some of the features that we have and the other NLP libraries don't, like date matcher, or spell checker, language detector, keyword extraction. Also, we have an active community on Slack and GitHub. You can ask any questions about Spark NLP on our Slack channels, then you will get a quick reply. We have public and enterprise versions. Spark NLP, you can work for all your NLP tasks like NER, information extraction, text classification, question answering, or summarization by using only Spark NLP. Also, we support more than 200 languages by using the same NER architecture. We have more than 4,000 pre-trained pipelines and models, which are trained for different purposes by using different kind of embeddings, like Glowbird or Albert. Spark NLP for healthcare is our licensed library, which is special for healthcare tasks. And we have also another library, another licensed library that was named as Spark OCR for processing PDFs, DICOM images, or clinical images to get the information inside. But we will not cover it today. In healthcare module, we have more than 600 pre-trained pipelines and models that are trained for different tasks in healthcare, like entity recognition, entity linking, assertion status, or relation extraction, the identification, chunk mapping, and more. Clinical entity recognition is the most important part in the most important stage in healthcare tests. Everything is built upon clinical entity recognition models. We have more than 100 clinical entity recognition models that are trained on different kinds of clinical data sets, like N2B2 challenge dataset, NBCI, or PubMed datasets, or we have some models that are trained on datasets annotated by our experts internally. After getting meaningful chunks, you can use these entities for different kind of tasks. Like if you get the disease entities or problem entities, you can assign their ICD-10 codes, or you can find the aristome codes of the drugs. Or if you are working on a clinical test and you need to check if a disease is related with the patient or someone else. You can use assertion status model for this, and for the negation status checking or checking the entities. Also, you can use the identification models and the identification components of our library to identify or obfuscate your sensitive information. Obfuscate means replacing with the fake ones the sensitive information. Maybe you can use these extracted entities and you can find the relations between them. This is the ideal result that we want to achieve at the end of the day by using all these components together. As you can see here, we are able to detect different kind of entities like age, gender, relative date, dosage, drug frequency, and find their relations. Also, find the aristome codes of the drugs and SNOMED codes of clinical findings. As you can see here, also we are able to calculate the risk adjustment scores of the patients by using the clinical tests. Clinical relation extraction is one of the most important tasks in healthcare domain. It is the task for predicting the semantic relationships between the detected entities. The role of relation extraction in NLP applications are question answering, summarization, clinical knowledge graph, or etc. You can use relation extraction for extracting the many kinds of information from clinical text. It can be used for detecting the temporal events between the clinical events, or you can check the drug-drug interactions, or you can find the frequencies and which frequency is related with which drug, or which treatment is used for which problem. If you are working on a task for detecting the adverse drug events, as shown in the example here, you may have more than one drug entities in a sentence, and also the ADE entities as well. So you need to check the relations between them. If a drug is related with these ADE entities or not. By using all our components, you can get a graph like this. As you can see here, CT scan abdomen. You can see the body. You can see the body part, or findings, or it was labeled as image technique, and this is the test for hematoma and the assertion status of hematoma or ICD-10 code of that, frequencies, prescribed drugs or doses like that. Here are the list of all our relation extraction models we have. We have several kind of relation extraction models trained for different purposes, like ADE and the drug relations, or temporal events, or the clinical test dates and findings. Like you can extract the relations between the drug-drug interactions and more. The thing only you need to do is search for the models on our models hub page. Then you will see a list of model cards, and when you click on them, you will see the descriptions, some sample codes, and the other details of these models. We have two different approaches while training our relation extraction models. The first one is fully connected neural network-based model. The second one is word-based model. Why we use two different kind of approach? Because it's for scalability actually. CNN is lighter than BERT, but you may have better results by using BERT-based model. As you can see in the picture, left side, the model checks, if you want to check the increased pain and the TLN over here, the relation between them, the model checks too many inputs, like pair embeddings or embeddings of the tokens from the left side, and 100 tokens from the left side and 100 tokens from the right side, then their positions and the dependencies between them. Then it returns a result if these entities are in a relation or not. In the birth-based one, it works like a sequence classification, end-to-end sequence classification. There are several challenges while training clinical relation models. Finding the clinical data is the biggest problem for training a clinical model, actually. Since the clinical data sets contains some sensitive information like PHI entities, you cannot share them with the third parties. And processing the clinical data sets requires spatial domain information, so you need domain experts to check them. Also, you need an annotation tool for annotating. And your domain experts should be trained on annotation. Also, the training resources are the common problem of training deep learning and machine learning models. If you overcome all of these challenges, then you will get a supervised model. This means you will have a model that was trained a set of labels, and you cannot use this model for another tasks, and you cannot detect the relations you cannot detect the relations if if this model doesn't have. Here is zero-shot learning comes in. What is zero-shot learning? It is a task for training a classifier on one set of labels, then evaluate on a different set of labels that the classifier has not seen before. Let's consider an example how a child would have no problem recognizing a zebra if he sees a horse before and read somewhere that a zebra looks like horse, but it has white and black stripes. He can easily recognize this. This means if you have adequate information about the object, like appearance, properties, or functionalities, you can easily classify or recognize this object. Zero-shot methods basically work by combining the observed and the non-observed categories through some auxiliary information which encodes observable distinguishing properties of the object. Recently, especially in NLP, it's been used much more broadly to mean get a model to do something that it wasn't trained to do. There are three common approaches in NLP for zero-shot learning. The first one is prompt-based. As you can see here, the GPT-3 is a good example for this approach. It was trained with 175 billion parameters, and the results showed us a zero-shot learning model has competitively good results with the extremely large language models for downstream tasks. And in Q&A based, it bases on asking questions and checking the answers for a relation. The NLI based is the one we used in Spark NLP. Let's take a deeper look on in NLI. As a quick review, NLI refers to one of the many types of downstream NLP tasks in which a model is asked to identify some relationship between two sentences, premise and hypothesis. NLI datasets are typically modeled via the sequence pair classification. So we feed both premise and hypothesis into the NLI model, then get a classification result. If the result is entailment, actually, if the premise and the hypothesis are are compatible, the result will be entailment. If they are incompatible, the label will be contradiction. If they are irrelevant, and the label will be neutral. In Spark NLP, we use NLI-based zero-shot learning, the clinical relation extraction model. This is how we use it. You can see a clinical text here. This is our premise. After taking Coumadin, experienced vomiting. Let's assume that we are working on a task for detecting adverse drug events. In here, Coumadin was labeled as drug, and the vomiting was labeled as problem by NER models. So we want to check if they are in an adverse event relation or not. To use our zero-shot learning model, we create an hypothesis. Creating a hypothesis is a tricky point in this model because it should be a hypothesis for this relation. For the adverse drug event, we created an hypothesis for like a drug causes problem. This is a meaningful, right? Then we feed these two sequences into NLI model. Then the NLI model checks the relationships between these two sequences, and if the result is entailment, the relation extraction model returns if these two sequences are in entailment relationship. This means these two entities have an adverse event relation. It is time for presentation. Let's jump into our notebook. Then I can show you some examples for how we use zero-shot learning in Spark NLP. We have a zero-shot clinical relation extraction notebook for you. The first thing you need to do is uploading your license and install the libraries that are necessary for Spark NLP, using Spark NLP healthcare model, like PySpark, public version of Spark NLP, and the Spark NLP GSL, which is our healthcare library, and Spark NLP display library, which is for displaying the results. I already uploaded my license keys and downloaded these libraries to not to take too much time. You can start your Spark session manually by using Spark Builder, or just you can use Spark NLP GSS start function to start your Spark session by providing license key secret. We have a sample text here. Paracetamol can alleviate headache or sickness. An MRI test can be used to find cancer. We create a Spark data frame here by using this sample text. Then we start. Let's take a look at our Spark NLP pipeline. We have a document assembler here. This annotator converts the text column into document type. Then we have sentence detector via healthcare module, which is trained for healthcare tasks, and it splits the healthcare text into sentences. Then we tokenize our sentences and use our word embeddings model. I used here embeddings clinical model, which is used for training these NER models. You can use more than one NER model together, as I did here. Yeah, I use clinical NER model, which can detect problem, test, and treatment entities in a clinical text, but I use problem and test entities by whitelisting them. Then I wanted to get the drug entities, so I used NER posology model. After that, to get a single NER chunk result, we merge these NER chunks by using our chunk merge approach annotator and get a single chunk. And here is for our relation extraction model. We use perceptron model to get the positions of the tokens. Then we feed its results into dependency parser model. Then we get the dependencies. After that, we filter chunks by using dependencies and merge NER chunks. Then we feed its results into then we feed our zero-shot relation extraction module that is used for zero-shot learning in relation extraction in Spark NLP. We use RE zero-shot BioBird model here. And here is the most important part. The model has not seen these ADE, improve, and reveal labels before. So we create hypotheses here. You can also assign more than one hypotheses, then assign a label for them. The model has not seen these labels before, so we create some rules, hypotheses here. Then the model checks the sequences, the premise, our clinical text, sentence actually, and the hypothesis together, and the NLI model inside our relation extraction model checks their relationship, and if they have an entailment relation, it returns these labels and which hypothesis is in entailment relationship. So the label will be that. We create a pipeline, then fit the model and transform data by using the model. Here is the results of our output of our zero-shot relation extraction model. You can see many different kind of informations in the metadata. Like let's check that in a Spark data frame. You can see that entity one and chunk one. This is chunk one, paracetamol. It was labeled as drug, and here are its beginning and end indices. And here is the second chunk, sickness. These are the indices of the second chunk, and its label here, problem. And our hypothesis here paracetamol improves sickness. The NLI prediction is for this hypothesis is entail, and the relation label is improve. For the reveal label, our hypothesis is an MRI test reveals cancer, so the NLI prediction is entail, and the label is reveal. You can see also the confidence scores here. Let's use light pipeline. Light pipeline is a special pipeline for Spark NLP. It is equivalent to Spark ML pipeline, but it is meant to get faster results by using a smaller amount of data, actually. If you have a data smaller than 50K sentences, you can use light pipeline to get a faster result. You can use these results for debugging or checking if you are doing something wrong or you are in a good way for your aim, actually. Then after creating the light model, you can annotate or full annotate. What is the difference between them? The difference between them is if you full annotate, you get the metadata, and if you annotate, only the results will be returned by the model. So we full annotate here and define a function to see the results in a pandas data frame. Can you see that? This result is the same with the results that we get before. So there's no difference between using the light pipeline and the Spark data frame according to the results. Let's visualize the results. Extracted relations. We use Spark NLP display library and the relation extraction visualizer component here to visualize the relations. Paracetamol can alleviate headache or sickness. As you can see here, headache and the sickness were detected as problem, and the paracetamol is a drug. So the model says that there is an improved relation between them. And also, an MRI test can be used to find cancer. There's a real relation between these tests and problem entities. Let's show another example here. After taking Lipitor, I experienced fatigue and anxiety. As you can remember, we created an hypothesis for adverse events of drugs. Drug causes problem. This was our hypothesis, and here is the result. Lipitor was detected as drug, the fatigue and the anxiety were labeled as problem. And the model says that there is an adverse drug event relation between these two entities. This is the end of my presentation. Thank you for listening. I'm done.
Great. Yeah, that was great. If you're good with
I
that,
hope,
then I can.
I hope it was great. I'm not sure, but
No, it wasn't bad at all. I can end the recording if you're comfortable with that, and yeah.
Yeah.
Okay, awesome.